Today's lesson is on 3-1 reflections. We're going to talk more about reflections on a coordinate plane and what that looks like for shapes and how you can graph these transformations as well. So a reflection is a type of transformation, which is when we change something. So an operation that maps an original figure called the pre-image, so the first figure, onto a new figure called the image. So basically we have the pre-image, the before, and then the image is the after, and we change it in some way. A transformation can change the size, position, or orientation of a figure. So how big or small it is, position where it is, and then orientation such as horizontal or vertical. So like a rotation, it can change that. So when you think of like an orientation of a photo that's horizontal versus a photo that's vertical, that's the orientation of the photo. So those are the types of ways we can transform a figure. So our first transformation that we're looking at in this unit is a reflection. So with this chapter, chapter 3, it's all about transformation, so changing a figure, and we're going to break them up into the different types of transformation. So the first one being a reflection, so reflecting something. So you have seen a couple videos on reflection. So some of this won't be brand new because you've seen it, but we're going to actually be practicing more with it today. So you have on the side here what a reflection looks like. So you have this triangle over here. So this is our pre-image, the before, and then it's reflected onto the other side. So what is that called? That's a flip over a line, this line, and it's called the line of reflection. So this line right here is the line of the reflection. It's what we flipped the figure over. And then you can see the notation here. We read these as A prime, B prime, and C prime, meaning like the after point. Each point and its image are the same distance from the line of reflection. So like the line of the reflection is in the middle of B prime and B. They're the same distance. All of the points are the same distance from the line of reflection. So all of the possible lines of reflection that we could have. So we can reflect figures over the x-axis, over the y-axis. We can do it over for vertical or horizontal lines, which you'll see in the form of x equals a number or y equals a number. And then we can also do it over diagonal lines in the form y equals x or y equals negative x, which are just these diagonal lines that run through the origin. So this is kind of all the information about reflection, and then I'm going to work through some examples with you. Should have warned you in the beginning, I'm not going to go through every single one of these. I'm going to go over just a few, and then you're free to practice some of the ones we don't do just on your own, but it's not required, but just to get the hang of it. So let's go ahead and start with example 1. So example 1 says triangle ABC has vertices, and it gives us the coordinates, and then it wants us to reflect it, and then it gives the new coordinates. So the first thing I'm going to do is graph triangle ABC with these vertices. So let's zoom in here. And remember, of course, basics of the coordinate plane. This is your x-axis, this is your y. So I'm going to start by graphing -4, 2. So I'm going to go over to the left, 4, 1, 2, 3, 4, and I'm going to go up 2 and put a point there. So this will be my point A. I'm going to label it. Then I'm going to graph 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And I'm going to label it B. And then I'm going to graph point C. All right, C is at 5, 1. So 1, 2, 3, 4, 5, up 1. I'm going to label that C, and then I'm going to connect these because I have a triangle. Okay, so there's my triangle. So what's really important is I have to know it's telling me what to reflect it over. It's saying reflect it over the x-axis. So this is my line of reflection. I'm going to create a mirror image of this figure onto the other side of the x-axis. So you're basically going to follow this same grid line that the point is on, and you're going to flip it over. So since I am reflecting it over the x-axis, this C is going to come right over onto the other side of the x-axis, and I just reflected that point. Okay, so I'm going to label it C prime. Now I just happened to do C first. I could have done A first. It doesn't matter, but notice that they're both one box away. So they're both 1 unit away from the line of reflection. And I'm going to label that point. So that's going to be it's still at 5 on the x-axis, but now it's at -1. So notice what happened here. Same x value, but the y became -1. So that's the same thing's going to happen with B. It's going to stay on 4. So it's going to stay on the x value 4, but it's going to come all the way down to now -7 instead. So it's, notice how it's 7 units from the x-axis. So it's going to also be 7 units now on this side, just down. So I'm going to count 1, 2, 3, 4, 5, 6, 7. And that's going to be B prime. So my coordinates for B prime are still going to be 4, but now it's going to be -7. And then same for A. So A is going to come down. It's at +2, so we're going to reflect it over, and it's just going to go to -2. So A becomes -4, -2. And then I'll connect those. So now you can see a reflection of this figure over the x-axis. Okay, so that's the first possible line of reflection, the x-axis. The next possible line of reflection is the y-axis. So now we're going to reflect it over the y-axis in problem number 2. So the first thing I'm going to do is graph the pre-image. Oh, I forgot to label over here. It's A prime. So rectangle. So now we're going to be graphing a rectangle, PQRS. So I'm going to graph these points first. So my first point P is at 1, 2. And then Q is at 2. 1, 2, 3, 4, 5. That's Q. Then I have R, which is at 8, 3. 3. And then I have S, which is at 7, 0. And so this is my rectangle. And I'm going to connect my points. And you can see the rectangle. So now we're reflecting this rectangle. Instead of over the x-axis, we're reflecting it over to the y-axis. So my y-axis here. So it's going to be a vertical, or it's going to be a flip over my vertical axis. So starting with whichever point. I just sometimes start with the point that's closest. So that P, I'm going to just reflect it right onto the other side of Y. And so that point right there is going to become P prime. Then I'm going to reflect Q. So Q is going to go right there. So you can see my line of reflection, y-axis is right in the middle. I've got 2 units here, 2 units here, 1 unit here, 1 unit here. So it's symmetric. All right, let's do R. So R is far away. So remember R, we went over 8 units. So this is 8 units from my y-axis. So I'm going to flip it 8 units over onto the other side. So it's going to go right here. And then my S, same thing. So my S, let me label this as Q prime, R prime, and then my S now, so 7 units over, it's going to go negative 7 units over here. And now I have my rectangle, and it's been reflected over. So my points, remember, so now we'll look at the values. So like P prime, it was at 1, 2. Now it's at negative 1, positive 2. So negative 1, positive 2. So my X value turned negative. Same with Q. So it went from 2, 5 to negative 2, 5. R went from 8, 3 to negative 8, 3. And S went from 7, 0 to negative 7, 0. So my X value is what turned into its opposite. So number 3 and number 4 are also going to be a reflection. Now I am going to have you try those on your own. And I want to go to some different types that we have. Okay, so I want to show you number 5, where if you look, we're going to be reflecting the triangle over the line x equals 4. So that's not the x-axis, that's not the y-axis, that's a whole separate line. So the first thing I'm going to do is plot that line for you. So when you have x equals 4, we're basically looking at the grid line of 4. So x-axis, y-axis. So you want to think, okay, you see how you have all these grid lines, right? You're looking for the one at x equals 4. So you go on your x-axis and you go to 1, 2, 3, 4. So let me label this here. We're at 4 right there. This is going to be my line of reflection. So I'm going to do a dotted line here to show you my line of reflection. So that's basically going to be the middle of my 2 figures. I'm going to be reflecting it over that line as opposed to the x-axis or y-axis. So let me start by graphing JKL. So I've got 1, negative 1 for J. And then for K, I have 2, 3. 1, 2, 3. That's K. And then for L, I have 3, negative 2. So 1, 2, 3, and then down 2. So I have a skinny little triangle here. I'm going to connect my dots, and then I will reflect it. So now, instead of reflecting it over the x or the y, it's going to go over here. It's going to flip over this middle line, and it's going to go over to the other side. So now you're still keeping in mind, you want each point to be the same distance from that line. So this K point, notice how it is 1, 2 units from the line of reflection. So it's going to go onto the other side 2 units from the line of reflection. So it's going to go right there. Okay, notice 2 units, 2 units. I'm going to label it K prime. And let's label what the coordinates are. So for K, I'm going to count 1, 2, 3, 4, 5, 6. And then I'm up 1, 2, 3. So if I try to kind of compare the original, I went from 2, 3 to 6, 3. So my Y value stayed the same and my X value increased by 4. So it's different now. It's not going positive to negative, negative to positive, like it is when you're reflecting over the X or Y axis. So now let's reflect this point, J. So J is 1, 2, 3 units. So 1, 2, 3 units from the middle. So I'm going to go for 1, 2, 3 units and put my point right there. And that's going to be J prime. So that point is 7, negative 1. And then I'm going to do L. So L is only 1 unit from the middle, so it's going to become 1 unit over there, and that'll be L prime. And the point there is 5 and negative 2. All right, so that's my reflection over a line x equals 4. So a little bit different. So number 6 is going to be a reflection over x equals negative 1. So that's going to be a reflection over a line right here. So I'm going to have you try 6 on your own. That's where the line would be. I want to go and I want to show you what it looks like when we're reflecting over the y, a line on the y axis, or not on the y axis, but a vertical line as opposed to, or a horizontal line as opposed to a vertical line. So I'm going to be reflecting CDF, a parallelogram, over the line y equals 2. So this is my x-axis, this is my y-axis. So I'm going to go onto my y-axis because it's a y right here. That's how I know. And I'm going to go to 2, which is right there, 2. And I'm going to draw a horizontal line through 2. So basically, we're reflecting it over this line right here. So first, let me plot my parallelogram. My first point is 1, 2, 3, 4, negative 4, and down 4. So 1, 2, 3, 4, down 1, 2, 3, 4, and that's C. Then I will plot D, which is negative 2, 0. So 1, 2, and 0. And then E, which is 6, 1. So 1, 2, 3, 4, 5, 6, up 1. That's E. And then F, which is 1, 2, 3, 4, negative 3. 1, 2, 3, 4, 1, 2, 3. Okay, so this is a parallelogram. So I'm going to connect these points. And then I'm going to reflect each one. So now I'm reflecting it over this line here. So remember, same distance from the line. So let me start with point E here. I see that point E is 1 unit from that line of reflection. So I'm going to put it 1 unit on that same grid line here. Oh, let me label, this was F right here. let's move F. Well, let's write the points here. This is E prime, and E prime is, it's my x-axis. For E, it's still 6, but now I went up to 3. So 6, 3 for E prime. Let's go ahead and reflect F. So notice F, my x coordinate's going to stay the same. So it's still 4, but it's how many units from this line of reflection right here. Let's count. So it's 1, 2, 3, 4, 5 units. So I'm going to count on the other side. 1, 2, 3, 4, 5. Right there. I'm going to go ahead and double count, make sure I count it right. 1, 2, 3, 4, 5. So 5 units there. 1, 2, 3, 4, 5. 5 units there. So that's how I know I plotted it right. So that's F prime. And for F prime, I'm going to put the coordinates as 4. And then I'm up here at 7. Now for D. D is 2 units from the line of reflection. So I'm going to go to the other side and count 1, 2, and put a point, and that's D prime. And lastly, let's do C. So C is 1, 2, 3, 4, 5, 6 units. So I'm going to count 6 units. 1, 2, 3, 4, 5, 6 units. Let me double count that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. Let's connect. So you can see the reflection. Looks good. If you imagine folding this paper in half, they should line up perfectly. And then my points for those are going to be for C prime up here. I'm at negative 4, 8 and negative 2, 4 for D. And there you go. So that's a reflection over the line y equals 2. So really it's just being careful with counting all of your units. All right, so I'll have you try 8. And then let's look at number 9. Okay, so now I'm reflecting it over y equals x. So if you look at the front of your notes, this is our third option. So we did over x equals a number, y equals a number. Now we're going to do over a diagonal line, y equals x, and y equals negative x. So the line y equals x is going to be a diagonal line. So you're going to draw it like this. The y equals x line runs through the origin, and it is on each grid point like that. So that's the line y equals x. Okay, so let's plot our triangle first. So I've got negative 5, negative 2, 1, 2, 3, 4, 5, and then down 2. So that's x. Then I have y, which is negative 3, 4, 2, 3, 1, 2, 3, 4. That's y. And then I have z, which is negative 1, 1, z. Okay, so now I'm reflecting diagonally here. So when I'm counting my boxes still, but it's going to be diagonal. So you're going to have to be a little bit more careful and precise with these so they're the same distance. So like when I do Z, I can see it's one box still diagonally. So it's going to go right there. That will be Z prime. So the coordinate for this point Z prime is 1, -1. Okay, so we went from -1, 1 to 1, -1. So notice what happened. We'll see if we notice a pattern with the other points as well. So let's try Y. So for Y, if I look at it, I am 1, 2, 3, about 4 when I count. So I'm going to be going down and it's going to be much harder. So I'm going to put the point 1, 2, 3, 4. Kind of looks like I'm right here. Okay, so let's check if that seems correct. Okay, so that looks like a reflection. Let's look at the point for that. All right, so what do you notice here? We went from -3, 4 to 4, -3. Let's look at our last point, Z, or I'm sorry, X. And let's see how we can figure it out. So I'm going to reflect this, X, and it's going to go to -2. So look how I kind of tried to make it like 1.5, 1.5. Now let's figure out what that point is. So it's at -2 down to -5. So what do we notice? From -5, -2 to -2, 5. So do you see the pattern here with all of those points? So there's a specific pattern when you're reflecting over the line y equals x. So your x values shift and it becomes y. So they flip. And we're lucky that there's a pattern there because if you notice, it's a little bit harder to count the distance from that line of reflection when you're on a diagonal, which is why we then discover that there's this pattern. And so we're actually just flipping our y and x value. So you're going to try number 10, but it might be easiest when you're plotting it to actually figure out your points first. So for example, if you know G is 2, -1, then you actually then know that G prime is -1, 2. And if you know that H is 7, -1, then H prime is -1, 7. So you're actually just flipping the points, and that makes it a little bit easier. All right, let's look at one last type. So that's y equals -x. So it's a diagonal, but notice this diagonal is going up, it's positive. We're going to look at the diagonal going down, negative. So the diagonal y equals -x goes down like this. All right, so we're going to flip it over this line now, and we'll see if we can find any sort of pattern here. Okay, so let's pop first A, negative 1, 3. Negative 1, up 1, 2, 3. That's A. And then I'm going to pop B, which is 0, 6, 1, 2, 3, 4, 5, 6. B. C is 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. And then D is 2, 2. So 1, 2, 1, 2. And I have a perfect square. Okay, so it's going to be a little bit of a challenge if I'm just trying to reflect this over. Okay, so I'm going to try to reflect these over by counting the distance, but you'll notice it's going to be a little bit harder. Okay, so like A is going to go right here. So you can see they're both like halves. They're both a grid point diagonally, okay? But let's put the coordinate of that and see if we can find a good pattern. So this point is negative 3, 1, okay? So what do we notice? We flipped again. However, we also flipped signs. So the 3 became negative, and the 1 became positive. So we went opposite signs. So let's try again with B. So B is going to be even harder for me to try to plot that reflection. So let's see if we can try the rule. So let's see if I flip 0 and 6, that's going to become 6, 0, but then it's going to become negative. Okay, so let's plot that point. So I've got negative 6. I'm going to go 1, 2, 3, 4, 5, 6, and then I'm going to go 0. So you can see these are equal distances from the line of reflection, and that's B prime. So let's try it with C. I'm going to flip them. So I'm going to go 5, 3, but then I'm going to make them both negative. So that's going to become 1, 2, 3, 4, 5, and then down 1, 2, 3. And you can see they are the same distance, just a little bit harder to tell. And then I'm going to do D prime, so let's switch it again. So they're both 2, 2, so really it's just going to become negative 2 for D. So I'm going to go to negative 2 and down 2, and I have a square that looks like that. Alright, so 12 would be very similar. So if we establish our rule here, we are flipping these as well, but we're also making them negative. Flip and negate, so make it negative.